Welcome to my YouTube channel Lenin 8. In this video, we are going to discuss about a Java program to print sum of prime numbers from 1 to 100. So we are going to make our logic as generic. So it's not only from 1 to 100, you can take any range of numbers like 100 to 200 or 100 to 1000. Our logic is going to work even for any given range. For example, I'm taking from 1 to 100. So if we add those prime numbers from 1 to 100, our expected output is nothing but 1060. Then how do we write the logic for this one? Before we proceed further, I recommend you to watch my first video of a printing list of prime numbers from 1 to 100. They're the same logic here I'm going to use, but with some more improvisation on the logic. Okay. What is that improvisation is nothing but previously if we take any number, say for example 10, to decide it's a prime number, we'll be checking each and every factor which is starting from 1, 2, 3 and so on up to 10. Correct? So in this part, we all know that 1 is a factor of every number. Then why to check this? Just to extend the JVM's execution time. So this is not mandatory. Yeah. And at the same time, every number is a factor of itself. Therefore, we can also reduce these two iterations for each and every number from 1 to 100. Therefore, 200 iterations of JVM, we are going to reduce it. That means our output will be a little faster than the previous logic. And if I take one more prime number, 7, 7 has two factors, that is 1 and itself. Correct? So if you are not considering this one and if you are not considering this 2, 7 also, then the number of factors are going to become 0. Now in this scenario, if the number of factors are 0, we are going to consider that as a prime number. If the number of factors are other than 0, then we are not going to consider that number as a prime number. So this is the improvisation which I am going to do in this logic. Yeah. So for this, first I am taking a for loop. So for int I equals to 1. So here no change. Then I should be all the numbers from 1 up to 100. So less than or equals to 100. Then I value should be incremented by 1 each time. So inside this for loop, we discussed clearly why we have to initialize count value here equal to 0. Why in this location? We discussed in the previous video. Right? Same thing I'm going to use. Next, the change which I'm making from the previous to this one to improvise the performance of the logic. I'm taking one more for loop, int, and the variable called j. And since we have decided that 1 is factor of every number, then no need to check. That's why this j loop I am starting from 2. And then j should run till less than or equals to, here is one more important point. For example, if we take 10, what are the factors of 10? Factors of 10 are 1, 2, 5 and 10. Yeah, so we are not considering this 1 and we are not considering this 10. 2 and 5, it means always for any given number, if you just make this number into half, 2 parts, there will be a factor from first half and there will be a factor from second half as well. Because of that pair only, we get a 2 combination of factors for this. 2 into 5 becomes 10. So I'm calling this 2 and 5 is a pair. If you take 100, what is the pair of factors? 1 and 100 is one pair of factors. And then 2 and 50 is another pair. So like this, there are multiple. So what I mean to say is once if we take this numbers into half, then whatever the half factor which is in the first half, there will be a pair for that in the second half. That's why instead of checking these 2 and 50, if you check only 2, it's enough, right? To decide it has one more factor or not, other than 1 and 100. That's the reason again I am making this loop to run faster by equaling that j is less than or equals to I by 2. It is because of this reason. It is because of this reason. The next followed by j plus plus. So what is the purpose of this inner for loop? To check and count the number of factors of every I value. That's why I'm writing a condition. If I modulo j double equals to 0, it means j value is a factor of I. So purpose of this one, to count the number of factors. That's why I'm taking it as count plus plus. This is the purpose of inner for loop. So then closing of this for loop. After this, we have to check the condition. What is the condition? If count previous logic of j value from 1 to j should be less than or equals to I, we have to consider if the number of factors are 2, it's a prime number, correct? Now with this understanding of not considering the same 1 and not considering the same number, now the number of factors must be 0 to consider as a prime number. That's why I'm writing count equals to 0. Then we need to write one more logic. I'll tell one more condition. I'll tell you what is that. Wantedly, I'm leaving some space. Then inside this condition, inside this if condition block, what we supposed to do? To get the list of prime numbers, you have to print the I value here. But now what's our requirement? You have to print the sum. That's why I'm writing sum equals to sum plus I. Then is sum is initialized anywhere? Nowhere, right? Then here before the outer for loop, here is a location. I'm taking int a variable name called sum, initialize the value to 0. And the same thing can be used inside this if condition. Then this is the purpose of even outer for loop as well. It is done. Then finally we can print system.out.println, system.out.println, print the corresponding variable name called sum, in which the output will be there as a for 1 to 100 it will be 1060. And here what is the leftover condition? Assume if I equals to 1. This is a situation where if I equals to 1 and the count value will become 0. I am writing only for one iteration. If I value is 1, then followed by outer I for loop condition will be true. That is 1 is less than or equals to 100. Then control comes to int count equals 0. Then a count variable also will be initialized to 0. Next, this for loop condition, for loop initialization int j equals to 2. Then the condition j is less than or equals to I quotient division 2. What's I value? 1. Quotient division means divide with 2. And what's the nearest smallest multiple? 0 times. Then here 0. Remainder will be 1. Forward slash will take the quotient as answer. Means j. That is 0 is, 2 is less than or equal to 0. True or false? False. Therefore, control will not enter into this for loop. Directly control will come here. Correct? Then if count is equal to 0, is the count remains 0 for 1? I value is 1, count remains 0 only. Then what has to happen? Sum plus I. What is sum value? 0. Then plus I. What's I value? 1. So it is counting the I value as a prime number into the sum. But is it a prime number? No. So this is only one concern for if I value is 1. That's why I am making this as I should be not equals to 1. This is the one more condition. So with this complete logic, so you get the sum of prime numbers for any given range of numbers. So for example, 1 to 100, then the output will be 1060. Hope you understood this reason as well. We execute the same program through Eclipse. To understand the same program through IDE, so first I have taken a class name is 8, and inside this I have taken a main method, and inside this main method I have created the object for scanner class, which is a class present in java.util package. So first I have imported that. Then we have created the object for the scanner class. Then I have used a print statement, system.out.println, enter two numbers like 1 to 100. Then we use a method-based approach for this. So I am taking one more class in the same file. I'll name this class as a prime. Class name is prime. Inside this class, I am considering one method whose access modifier is public, then return type is void. Then method name is some get sum of prime is a method name. And this method I am taking two inputs like 1 to 100. So 1 should be one of the input. So int n1 I am considering that, and then followed by one more input, say int n2, two numbers. So inside this, whatever the logic that we discussed, is the same thing that I am going to write. First take one variable int whose variable name is sum, whose value will be initialized to 0. Then followed by first for loop. So for int I equals to. So previously we wrote directly 1, but now instead of 1, I'm using this variable name called n1. Then I should be less than or equals to not 100, it's n2. And then followed by each time I plus plus. So this is the outer for loop condition. So inside this, yeah, sorry, here semicolon. Inside this for loop, we have to initialize the count to 0. So int count will be 0. Then followed by in a for loop, say for loop int j equals to. So here is the improvised logic of j should start from 2 to reduce the 100 iterations for all the numbers. Next, j should be less than or equals to which one? I by 2. Next, j plus plus. Then inside this j for loop, what is the condition to write? If I modulo j double equals to 0, it means we are counting the factors. So inside this if condition, I'm writing count plus plus or count equal to count plus 1. Anything is correct. Then outside inner for loop, inside outer for loop. So here is one more condition. What is the condition? Count. Count should be equal to 0 or count should be equal to 2. 2 considered a prime number with this logic. It should be 0. And what's the next condition we discussed? And I value should not be equals to 1, because for 1 it will be counted as a prime number we discussed already. Then here I'm writing sum equals to sum plus I. We can write sum plus equals to I as well. Yeah. Then where we have to print it? So we have to print outside the outer for loop. So you can see here. Here is the starting curly brace of outer for loop, and here is the closed curly brace of the outer for loop. Then after this, we have to use a print statement system.out.println, print the variable name called sum. Yeah, that's it. And to execute this method, we have to create the object for this class. Before that, by using the scanner class, how do we read the integers? So I'm taking sc dot, the method is nothing but next int method to read integers from keyboard. So I'm taking this first one and I'm storing into some variable of program or choice, which is of int type, some int x equals to. Then the same thing, I'm going to read one more input from the keyboard for a second value of range. Then I'll copy, I'll paste it. And since we can't use the same variables, I'm making this as y. So this is how we read the input from the keyboard as integer values. Then followed by, I'm creating the object for the class. The class name is prime. Some p equals to new prime. And to call the method, object variable dot get sum of prime is our name. And n1 and n2 are two integers. The same thing we are reading by using x and y variables. So my Eclipse IntelliSense is supporting that. Let me save this one and let us execute by Control F11. Now from the console, it is asking to enter two numbers. So 1 and one more number, I am entering it as 100. So 1 and 100 are given as inputs. Then if I press enter, what's supposed to be our expected output? It is 1060. And to cross verify, you can just take the range of numbers again. I'm taking 100 and 1000. It means we are finding the sum of prime numbers from 100 to 1000. Let me press enter. It's 75,067. So this is the generic logic which will work for sum of prime numbers from any given number to any other number. I hope you understood. And for your more questions and also for your feedback, please use the comment section. Thank you.